this next exercise there is nothing new here. It is the same kind of stuff that we were just doing. Some of them will probably be slightly harder. These are, if you look at the top, they are HSC questions, I'm pretty sure all of them. So this was in the 2010 paper, question 5, if that means anything to anybody. But 5A to be exact. So feel free, you could go ahead and see if you could attempt parts of these questions by yourself. As I said, the more of these you do, the easier this will become. So a rainwater tank, so our cylinder again, is to be designed in the shape of a cylinder with a radius r and a height h meters. The volume of the tank is to be 10 cubic meters. I'm sure that's going to be important. Let A be the surface area of the tank, including the top and the base, in square meters. It says, given that A equals pi r squared plus 2 pi r h, it's giving you the formula for surface area. Show that A is equal to 2 pi r squared plus 20 over r. What is the difference in those two equations? So I said I'm giving you this and I want to get to that. I need to eliminate the h. Okay, so I need to find an equation for the h so I can put it into there and get rid of it so that there's only r's in my equation. So the thing that I was given, even though this question seems to be all about surface area, I was given a volume. Okay, so that is what I'm going to use to get rid of the h. The volume of a cylinder is pi r squared h. The volume that we've been told is 10. So it's 10 pi r squared h. And to get the h by itself, we divide the pi r squared across the other side. So that means all I have to do is substitute that value of h into that equation there to get the second one. Okay, so A for area, surface area, but they only like one letter for these things. Area is equal to 2 pi r squared plus 2 pi r, and I'm subbing in that h is equal to 10 over pi r squared. So we have some cancelling. Pi on the top, pi on the bottom. R on the top will cancel one of the r's on the bottom. And I get my equation 2 pi r squared plus 2 times 10 is 20 over the r that still remains on the bottom, which was the second equation that I had to get to. Okay? Obviously, because they give you the answer in these questions, it's all about how you get there. Make sure you show the steps. Part B, show that A has a minimum value and find the value of R for which the minimum occurs. Okay, minimum value, differentiate. So first of all, let's change our equation for A to get that R off the bottom. So that will be 2 pi r squared plus 20 r to the negative 1. The derivative, should be getting good at this now, timesing the 2 down will give us 4 pi r. Then the second term, bring the minus 1 down, so negative 20 r to the negative 2. I want the derivative to be equal to 0. So that means the 4 pi r will be equal to the 20 over r squared. You'll find these questions are quite long already. You probably will want to do a little bit of rearranging early on. Times the r squared across the other side. So 4 pi r cubed equals 20. To get the r cubed by itself, we do the 20 divided by 4. We could do that straight away, that's 5. And I would still have the pi on the bottom. Is that okay with everybody? Yeah?
Yes.
No? Yes? Good. Okay, then I need to cube root, which is not so nice because I can't cube root any of that. So cubed root of 5 over pi. I'm going to leave it like that for now. Okay, so I need to know whether that is a maximum or a minimum. So what do I need? Very true. So the second derivative, a double dash, equals from looking up here, so 4 pi r, differentiating that will be 4 pi. Second term, bring the negative 2 down, times with the negative 20, we'll make a plus 40 r to the negative 3. So that is 4 pi plus 40 over r cubed, if you want to put it back in fraction form. And I need to sub in my value of r. So when r is equal to that really lovely number, cubed root of 5 over pi, potentially we could do this as a decimal from here because we're only really interested in the size, not an exact solution here. We would sub that into our second derivative. That is 4 pi plus 40 over, now this actually is nice because it's over, my formula says r cubed, and if I'm putting in the cubed root of something, it actually, the cube and the cube root cancel each other out. So it would just be a 5 over pi on the bottom there. You wouldn't need the cubed root anymore because I've cubed it. Yeah? And again, I'm doing all this exact when I really could just have a decimal, but that does make 4 pi plus 8 pi, which would make 12 pi. Look at that, did it all exact, just for fun. Okay, doesn't matter that it was exact, all that matters is that it was greater than 0. Okay, because that is greater than 0, that means that we have a minimum when r is equal to the cubed root of 5 over pi. It always pays to just go back and read the question to make sure you found all the parts in case they want you to find the surface area or something. So show that A has a minimum value and find the value for R. Yep, done it. There's nothing else to do. Okay, next one. You're going to need to keep moving. Question 2. This is 2005. Was the other one 2005 as well?
2010.
Oh, 2010. All right, question 8. Maybe question 8 will be a little bit harder than question 5. All right, let's go. So we have a cylinder again. A cylinder of radius x and height 2h is inscribed in a sphere of radius capital R at center O. O is the center of your sphere, as shown. Show that the volume of the cylinder is given by V equals 2 pi h bracket r squared minus h squared. Okay, so in my diagram, I have little x, little h, and capital R. Please notice that one of those letters is not used in the equation that I want for volume. Okay, so the equation that I have down here has the capital R and the height. It wants it to be in terms of the radius of the sphere and the height of the cylinder. I do not want to have any x's in there. I don't want the radius of the cylinder in there, okay? So I need to have some kind of relationship that is going to help me get rid of the x from my equation. Can you think of anything? Perfect. Those 3 sides are in a right angle triangle. I could do Pythagoras' theorem to have them in a rule. So the radius, r squared, would be equal to x squared plus h squared. Or you could have gone straight to x squared equals capital R squared minus h squared. Okay, just got to show that it's Pythagoras' theorem that we're going to be using there to be able to get the x out of my equation. I could square root that, but you're going to find that we don't need to, because now let's think about the volume of a cylinder. Again, what is the formula for the volume of a cylinder? Yes. Okay, my cylinder has a radius of what? The cylinder. X is the cylinder, so that's going to be pi x squared. What is the height of my cylinder? 2h. Okay, so that's using the direct dimensions from my diagram. Radius is x, so x squared, and the height of my cylinder would be 2 lots of that h there. But I don't want x in my equation, so this is where I now go x squared, which is why I didn't square root it, because there's an x squared. I'm going to replace the x squared with this. It will be pi, instead of the x squared, r squared minus h squared times by the 2h at the end. That is pretty much exactly what I have above. I just need to put it in the right order. See this? The 2 pi, my 2 is here, my pi is there, and the h. 2 pi h, I do have them all, they're just spread out. And there's my r squared minus h squared. So let's just put everything out the front. 2 pi h bracket r squared minus h squared. All right, got the equation. Part B. Hence or otherwise. Don't you love the or otherwise? Where you go, what else could I do to get this? But anyway, hence or otherwise, show that the cylinder has a maximum volume of when h is equal to r over root 3. Differentiate, yes. So I'm not going to differentiate brackets. I'll have to expand that out. So that's going to be 2 pi r squared h minus 2 pi h cubed. Interesting, because I've actually still got 2 different pronumerals in this. What am I differentiating? I'm trying to show that it has a maximum. I'm trying to maximize the height. So it is the height that I need to differentiate. So for this one, it is not ideal to be putting a V dash here, because I would then be going, which one are you differentiating? Have you identified which pronumeral out of here are you differentiating? So it's best if you went to long version for this, so you're indicating I am differentiating the volume with respect to the h in the equation, not the capital R. I'm only differentiating the h. So differentiating the h means you're treating the r like a constant. It's just going to be sitting in there. So this h here, because there's only one of them, it's just going to disappear, and this first term will be 2 pi r squared. In the second term, differentiating the h, the 3 comes down the front, so it'll be minus 6 pi h squared. I need to make my derivative equal to 0, which means my 2 pi r squared will be equal to my 6 pi h squared. Remember, I'm trying to get the h. The r is just sitting in there. So I could divide by pi on both sides. That would get rid of that straight away. And I'm going to keep my h squared, and I would have 2r squared over 6. Now the 2 over 6 also simplifies to be just an r squared over 3, cancelling 2 out of top of them, top and bottom. To get the h by itself, I square root. Square root of r squared is just r. Square root of 3, unfortunately, has to be square root of 3. Tempting to put plus or minus, but again, thinking about the practicality of this situation, the h represents a height. It's not ever going to be the negative number. Okay, so don't need the negative version of that. To find out whether I have found a maximum, second derivative. So d squared v over dh squared equals, and you can just see my first derivative at the top there. So the second derivative of that, you bring no, I don't bring the 2 down because I'm not differentiating r. So this whole thing here is just a constant if I'm differentiating h. So that whole thing will disappear. It's only that h there that I need to differentiate. So minus 12 pi h. Very good. Sub in my h. So when h is equal to r over root 3, I get d squared v over dh squared equals minus 12 times pi times r over root 3. Now, we can't really work that out because we don't know what r is, but this is positive, and this is negative. So overall, the r would also have to be positive because it's a side length. Okay? So overall, that whole thing there would need to be a negative result because of that minus 12 out the front. So it would be less than 0, which means that we have a maximum. Maximum when h is equal to r over root 3, which was what we had in the question. Okay, we're not doing too bad. Question, there's only one more question that goes for 2 pages. 2015 question 16C. You know, as the numbers go, in the HSC exam, it's a bit sad that they do this, but they do tend to get harder as you go through the paper. So question 5, you go, oh yeah, that's kind of towards the beginning, won't be too bad. Then question 10, question 16. All right, so, all right, let's do this. The diagram shows a cylinder of radius x and height y inscribed in a cone of radius r and height h, where r and h are constants. Okay, so they're constants, not going to be differentiating those. We have a diagram. We can see our cylinder inside our cone, which is good. The volume of a cone of radius r, it's given me the formula, is 1/3 pi r squared h. So a lot of the time they give you the volume formulas, which is good. You might have forgotten them. And we have our volume of a cylinder. We've used that at least 3 times today, pi r squared h. Show that the volume of the cylinder can be written as V equals that very lovely equation right there. So again, we're looking at what letters do I need in my equation and what have I got in my diagram that I can use. So I've got little x, I've got r, that is, and h, sorry, there's a h, capital H. So I don't want the little y. Okay, so there's 3 pronumerals in here, there's 4 up here. The one that I don't want is the y. Now, here is the challenge. Sometimes it's just getting started is the hardest part. How can I make a relationship between those 4 pronumerals that are in that diagram? I'll give you a second to think.
You do the r minus the x and then make a triangle in there.
Yes. Yes. It does involve triangles. Definitely on the right track. Here, I'll draw your diagram. This will help. Here is a triangle. And here is a bigger triangle. Any ideas now? Yes? What am I doing with those triangles? Similar triangles. They would be similar triangles, and I could use the ratios of the sides. Yes. Yes. All right.
You haven't done that since like
Year 10. You did it in year 10. All right. We are going to be using similar triangles. Just goes to prove even year 10 stuff could be handy. We haven't done similar triangles in year 11. But here it is. Okay, similar triangles means that the ratios of the sides must be in proportion. So the little triangle has x, looking at the horizontal sides first, I'm going to have x would correspond with the r in the big triangle. Yes? So x over r is going to be equal to, so I'm doing little triangle over big triangle, okay? So I've got a little triangle over big triangle. Now I need little triangle again. What is that height? Yes. This height of the little triangle is h minus the y. So that's a bit of a tricky bit. H minus y over height of the big triangle, which is h. Now remember, I don't want the little y. So I need to rearrange all of that to get the little y by itself. So let's first of all keep the h minus y. I'm going to times the capital H across to the other side. So that would be h times the x over the r. When you multiply to the other side, you only multiply to the top. Okay, just make sure your algebra's understanding's good there, okay? All right, now to get the negative y, I effectively want to move the y across here to make it positive, and then I'll subtract that whole term back that way. Can I do that in one move? Yes. All right, so the y is going to be the h minus the hx over r. Now, I'm going to get a common denominator because I think that will make it easier for the next one. You probably could do it without, maybe one of you wants to try it. But to get a common denominator of r, so it's all one term, the first fraction I would have to multiply that h with an r minus hx. It already had the r on the bottom. Okay, so there is what y is equal to. But that's not what I was after. Remember, I'm after the volume. The volume of a cylinder. Yet again, volume of a cylinder is V equals pi r squared h. Looking at the diagram that you can't see on my screen, what is the radius of my cylinder? X. Pi times x squared, or pi x squared. What is the height of my cylinder? It is the y, which instead of writing y, I can write down hr minus hx over capital R. Such a lovely equation, I know. Then, what can I do? I can pull a h out of the top. I've almost got the answer. So I can pull a h out, and I would get h, yep. Can I bring change? Oh, I won't change the order yet. I'll leave the pi x squared there. If I bring a h and the r out on the bottom, then it would give me the r minus x from the top. Yeah, can you see how I've done that? Taken a h out of each of those terms and also brought the denominator out. Because I'm trying to get to here, so all I need to do is bring that h over r out the front, and I've got it in the right form. All right, there we go. We have made our equation. Next page, we're pretty sure we know what's going to happen here. Just, guys, that's my page. It is a whole page of working. Don't write big. Okay, part B. By considering the inscribed cylinder of maximum volume, show that the volume of any inscribed cylinder does not exceed 4/9, 4/9 of the volume of the cone. 4/9, not 4/9, 4/9 of the volume of the cone. So we're trying to find a maximum. To start with that part. If I'm trying to find a maximum, it means I need to differentiate. Don't want to differentiate brackets. So let's expand that bracket. Well, maybe let's bring it back. Can I bring it back? There it is. Let's expand that bracket out. So it's V equals, oh, no, I can't write that low, sorry, have to move it up. V equals the HR pi squared x times by the R. What's going to happen? The R is going to cancel the R on the bottom, so it would just be H pi x squared, times in the first one out. You know, everyone's following me? It's just that times that, the R on the top and bottom cancelled out. Then I'm going to do all of that times by the x. Unfortunately, no cancelling out there. That's going to be minus H over R pi x cubed because of the x squared times another x. Now I can move that up because I've got my equation. Yes? Yeah. All right, differentiation time. And I have lots of letters in there, so we should be good. What am I differentiating? I'm differentiating the V with respect to what? The x, good. So, differentiating the x and treating everything else like constants. The squared will come down the front, so it'll be 2h pi x. If you miss a letter, change a letter that's a h to a pi or something like that, you've got to be really careful, okay? Tiny little mistake can change the whole result. The second one, bring the 3 down, so that would be 3 times the h over r pi x squared. As always, we want when our derivative is equal to 0. So I'm going to straight away, like I've been doing for the last few questions, move that negative portion across the other side. So 2h pi x equals 3h over r pi x squared. I am trying to get the x by itself. Now, let's do some cancelling, because that's going to be helpful. We have a pi on this side and a pi on that side. So dividing everything through by pi, they would cancel off. We also have a h on this side and a h on that side. That would cancel off if I divided through. And I know I'm trying to get x by itself, but if I was to divide this x across the other side, it would cancel off the squared. So all that is left, if I'm trying to get the x by itself, it's currently on the left-hand side, I have a 2. I would multiply this r up across to be with it, so it would be 2r. And then the 3 from the front here you would divide underneath. You could do it in more steps if you needed to. X is equal to 2r over 3. Yeah? To find out if that is a maximum or a minimum, we need our second derivative. D squared v over dx squared. Remember, we're just differentiating the x. So x is here, just one of them, so it's going to be all those things in front of it. 2h pi. Oh, I need to turn my h into a pi. 2h pi. And then the second term, I want to bring the 2 down and multiply it with the 3. Would make a negative 6h over r pi x. All right. I need to sub my x value into that to see if it's a maximum or a minimum. So when x equals 2r over 3, my second derivative is equal to, all right, the first term is just 2h pi, there's nothing to sub in there, minus 6h over r, still nothing to sub in, pi, it's only the x on the very end, which is 2r over 3. What can I cancel? What can I simplify there? Nothing with the 2h pi yet, but we have got r on the bottom, r on the top, because they're multiplied. We have got the 3 and the 6. Good, so I could divide the 6 divided by 3 gives me a 2 on the top, and a 3 on the bottom would cancel off. So there's actually no denominator left there at all. There is a 2 times 2, which is 4, a minus 4, and a h and a pi. Coincidentally, they are like terms. Look, h pi, h pi. So 2 minus 4 h pi would be negative 2 h pi. Don't know what h is. Pi's we do know, but we can see that it is negative, which means less than 0, therefore maximum when x equals 2r over 3. Okay, so success. We have done the first part of the question. It says, by considering the inscribed cylinder of maximum volume. Okay, so we found the maximum volume part. But we now need to show that the cylinder does not exceed 4/9 of the volume of the cone. We now need to compare the volume of the cylinder with the volume of the cone in our original diagram. All right, cylinder first, because the cylinder is what we've been dealing with. To find the volume of the cylinder, look back, we had a formula for it. And I'll write down volume of cylinder. The volume equation that we found right at the beginning was V equals H over R pi x squared R minus X. Okay, that was our equation. Don't need to find it all over again. But we now have an X value that we can sub into that. So let's put it in there. So when x equals 2r over 3, what's the volume going to equal? Volume equals, okay, h over r, nothing to sub in there, pi. The x needs to become the 2r, ooh, wait a second. Yeah, all right, I'm going to keep going. All right, so the x is equal to the 2r over 3. Sorry, I just had a look at did something interesting in there. Okay, squared, bracket, r minus the x again, which is 2r over 3. Okay, what can I do? Let's expand the bracket out. But we ought to do both, but maybe we should do one at a time. So h over r times 4, because square the 2, pi r squared over 9. Then we would have r minus 2r over 3. Actually, I should put those together. What is r minus 2r over 3?
That pi also needs to times with 3.
No, it only times us to the top. Only times us to the top. In the bracket here, if I want to push those together, let's make that a 3 over 3 there, so that we have a common denominator. Because then I have 3r minus 2r on the top, which would be a 1r, or just r, over 3, which is going to let me do more simplifying. Okay, yes? So what I did was I made a common denominator, so I had a denominator 3 here. So to get a common denominator, I wanted that one to have a denominator 3, so 3 on top and 3 on the bottom. Okay, so let's cancel off. Oh, we've got a little bit of cancelling. I can cancel that. I'm going to cancel with that one, just because they cancel completely. And I have got, let's be careful here, 4 pi h r squared over 9 times 3, which is 27. Okay. We now need to find the volume of the cone. And hopefully there'll be a nice little ratio we can get here. So volume of the cone is going to... What is the formula for the volume of a cone?
1/3 pi.
Yes. 1/3. What is the radius of the cone in the diagram on the last page? I believe it was capital R, wasn't it? Yep. Capital R was the radius of the cone, and the height was the capital H that we've been using. Sub in our value for, well, we need, what do I need? I need to compare it with the other one. I need pi, actually I think I've got it already. I've got pi r squared h on the top, and I've got a 3 on the bottom. So if I want to compare those two volumes, let's see how both of them have got a pi r squared h in them, right? So what I'm going to do is I want to divide the volume of the cylinder divide by the volume of the cone to see if I can get that 4/9. I'm trying to show that it doesn't get bigger, because that's the maximum volume of that cylinder in there. I want to make sure that it doesn't exceed 4/9 the cone. So the volume of the cylinder was 4 pi h r squared over 27. And I want to divide that by the volume of my cone, which was pi r, capital R, sorry, squared h over 3. Okay, Lachlan's time to shine, to divide those fractions.
Leave it, kiss it.
That's right. So let's do 4 pi h r squared over 27 times 3 over pi r squared h. And this is where the fun happens, because just about everything cancels out. Pi on the top, pi on the bottom, h on the top, h on the bottom, r squared on the top, r squared on the bottom. All that is left is numbers, and even the 27, we can divide that by 3 and get the 9, and that 3 cancels off. And there is the magical 4/9.